All right, so we did the first increasing and decreasing example. We're going to go back and finish the second one. So just a reminder on this is that the increasing part of the graph is where it slants up to the right. The decreasing part of the graph is where it slants down to the right. And so I think the easiest way to figure out what part is increasing and what part is decreasing is to take a stick figure and draw a stick figure on the left side of the graph. We always go from left to right. So if this stick figure started walking, is he walking uphill or downhill? He's walking uphill. And then he gets to the vertex. And then which way is he walking? Downhill. So increasing, hits the vertex, and then he starts decreasing. And then what we need to do is we need to label the important x values. And I know that they are x values because increasing and decreasing, you're always labeling x's. Yeah.
Is there a way to turn that off? Is it clear? Is that
yeah, you can turn it off. So always doing x values. So the first x value we're going to look at is a left arrow. What number do we have for a left arrow? Left arrow is? What number is a left arrow? Negative infinity. Goes left forever. What number do you use for a right arrow? Positive infinity. And then what x value do we use at the vertex? It's an actual point. It's got an x and a y coordinate. Can you see what the x coordinate is? -5. Perfect. So the increasing interval, the word increasing, is written between this x value and this x value. So that's what we're going to write down. We're going to write down negative infinity to -5, left to right. So negative infinity to -5. So the infinities always get parentheses. The number only gets a bracket if the stick figure is actually walking uphill at that number. So when the stick figure is right there at the top, when the stick figure is right there standing at the top, is he walking uphill when he's standing at the top? Is he walking uphill if you're standing at the very top? No. So we're going to do a parenthesis. Okay, the word decreasing is written in between these two numbers, -5 and infinity. Again, we're going from left to right, so we always write the smaller number first, so -5 and infinity. The infinities always get brackets, or parentheses. Okay, again, if I have the stick figure standing right here, is he walking downhill when he's standing right there? Is he walking downhill when you're standing at the very top? No, you're doing nothing, right? You're not walking uphill, you're not walking downhill, you're just at the top. So because you're not doing uphill or downhill, we just put parentheses there. Yep. Okay. So the next part is where we had the maximum and minimum. So we did one answer where there was a maximum of the graph, there was a highest point of the graph. Now they're asking us to do an example where there is a minimum of the graph, where there is a lowest point of the graph. And it says to put the minimum anywhere we want. So I'm going to make it right here. if it's a minimum of the graph, and it doesn't matter where you put it, so your point doesn't have to match mine perfectly. If it's a minimum of the graph, should the graph be right side up? Should it be a regular shaped V, or should it be upside down?
Upside down.
So if the graph is upside down, that makes a minimum. If the graph is upside down, that's a minimum. That's the lowest point of the graph. So it should be right side up. Okay. So if you want a minimum to the graph, you have to graph it right side up. So I just took my vertex and then I'm graphing my V to go the upward direction. And the vertex that I drew happened to be at -5, +2. So for maximum, I'm going to say none. There is no max for this graph. And then for minimum, I'm going to say -5, +2. So there's no max, but there is a min. Okay, when you're done writing that, go ahead and flip the page. Mm-hmm. All right, next one. The X-Intercept is where the graph crosses the X-axis. Where the graph crosses the X-axis, the Y value equals 0. So the point is always written as a number for X, comma, 0 for Y. The Y-intercept is where the graph crosses the Y-axis. The X value always equals 0. So the point is always written as 0 for X and a number for Y. So if you guys look at example 7, can you tell what the X-intercepts are and what the Y-intercept is? Yeah. What are they? Whichever. What do you guys see? Okay, so Y-intercept is 2, so we're going to write 0, comma 2. That's the Y-intercept. So we've got -6, and then what else do we have? 2. Yeah. So -6, comma 0, 2, comma 0. That's our X-intercepts. And then 0, 2, there's our Y-intercept. Okay. So sometimes with these graphs, you're going to have something like example 7. They're really easy to find. You don't need a calculator. You can just see them on the graph. And then I gave you a problem like number 8 on purpose, where I put pi in the problem and I forced the answers to be decimals so that we would have to find them using a calculator. So we're going to get our calculators out and we're going to make sure that we know how to type this in. Okay, so on our calculators, does anyone remember how to clear a calculator? It's more complicated than that, yeah. So we start with the second button. We start with this blue button. Second. Yep. Hit the second button. No, there's more than that. Because mine says clear also, but there's more than that. So hit the second button. Anyone know what to do next? Then hit the plus button. So second plus. And then 7, 1, 2. So second plus 7, 1, 2. What that does is it clears what's on your screen, but it also clears any funky stuff in the memory of the calculator, so that if you were using the calculator in chemistry, then you can come back and use it in math class, and it doesn't have any like weird window or weird looking stuff in it. You just get it all back to normal to use in math class. Does that make sense?
Yeah.
Okay. Also, if you're taking a test and your calculator does something weird, like it doesn't act the way you want it to act, you can clear it, plug the stuff back in again, and it will probably work the second time. Okay? Does that make sense? So second plus 7, 1, 2, anytime somebody has a problem with their calculator, that's what I use to fix it. Yep. No. Clear only clears the screen. That clears the calculator. Does that make sense, the difference? Second, the blue button? Oh, that's fine. Yeah, if you start typing, it'll get rid of that. Yeah. Okay, so we are going to go to the Y equals button, which is right up here. Mine doesn't say it because I rubbed it off, but it's there. So Y equals, right here. Right there, Y equals. That's the button you're going to click. And the screen looks like this. Everyone got it? Okay. Next, we're going to type in the 2 that's in front. So everyone hit 2. Next, we're going to type the absolute value sign, and the way that you get that is you hit the math button right here. Math button. And then you go to the second column. We're going over to number. It's a type of number, so we're going to hit the right arrow, go over to number, and it's the very first one, ABS for absolute value. ABS for absolute value. Now, this is a great way to see if the calculator you're working on has been updated or not. If it's updated, it will look like mine. If it's not updated, it will say the letter ABS. Does anyone have a calculator that is not updated? It says the letter ABS. Yeah? Okay. So anyone who has one that says the letter ABS, I want you to bring your calculator up to my desk. When you're done with it, I do not want you to put it back in the bin. I'm going to update it. Okay, so eventually we have all updated calculators. Okay, so next you're going to type X minus 1. The X button is right here. It says X, T, theta, N. So we're going to type X. And then we're going to type minus 1. X minus 1. Everyone got that? Now, we want to get outside of the absolute value sign. Cadence, you want to get outside of that parenthesis you have. So we're going to hit the right arrow to get outside of that absolute value sign. And now we're going to hit another minus because we want to do minus pi. Now, the pi is above the up arrow, and it's in blue. And anytime you want something in blue, you have to hit that second button that is also in blue. So anytime you want something blue, you got to hit blue first, okay? So you're going to hit second up arrow, and that's how you're going to get the pi on the end. So second up arrow is going to stick that pi on the end for you. It's kind of like the shift key on a computer. Okay? It'll close it automatically. Or no, you should close the parenthesis. Sorry, I forgot about that. Good question. Second up arrow, this one right here, underneath the clear key. Okay. And then everybody should have the equation written. Is that what everyone has? We all good? We all got it? Okay. All right. Over on the right, so over here on the left, this is what we hit when we wanted to type the equation into graph. And then all the way over here on the right, this is what we hit when we want to see it. So go ahead and hit this graph. There's your V-shaped graph. And it should look like what's already graphed on your paper. We don't need to zoom. We're going to leave it. No zoom. Okay. Everyone see that? What were we supposed to do? What? This part? Oh, just graphing it? The graph over on the right. Yeah. Mm-hmm. Okay. Does everyone have it graphed? Yes? Jordan, you got it graphed? Yeah? Okay. So now what we're going to do is we are going to look for the X-intercepts. We're going to look for the Y-intercepts. Okay? Now, the X-intercepts, we're going to go up here in our notes. We're going to circle this part. It says Y always equals 0. Another word for Y is function. If they ever ask about the function, they're really asking about the Y coordinate. So the X-intercept is where the Y equals 0. It's also where the function equals 0. The X-intercept is where the function equals 0. So sometimes people call the X-intercept the 0 of the function. They call it the 0 of the function. So we're going to go over here. We're going to say the X-intercept is also called the 0 of the function. That's another thing that it's called. Okay? So I'm going to show you guys on the calculators how to get to a menu so that you guys can look up different things about the graphs. So on that menu, we're going to be able to find X-intercepts. On that menu, we're going to be able to find Y-intercepts. We can find more things, but today we're only going to find X-intercepts and Y-intercepts. Okay? So to get to the menu, we calculate these different things. So we do second, and then the trace button right next to the graph button, there's a trace button, and above that trace button you see in blue calculate. So we're going to do second trace, and it allows us to use the calculator to calculate these different things about the graph. So the first one is just a value. It says if I plug in an X value, it will give me a Y value, so that's nice. The second one is it will calculate the 0 of the function, which is just another word for X-intercept. It will calculate the X-intercept for us, okay? So we're going to do option number 2. Now, some teachers teach scrolling left and right with the buttons, like scroll to the left, scroll to the right, and that you can help the calculator know where to look for the X-intercept. I sometimes do that, but I usually like to do it using the numbers on the screen. So if you look over here, I can see that the X-intercept is right here. It is somewhere between -1 and 0. But I'm lazy. I don't like to look that close to find my X-intercept. I like to just say it's somewhere on the left side. Would you guys agree with that? It's somewhere on the left side. And to me, the left side of the graph is somewhere between -10 and 0. You guys agree with that? Okay. So the calculator always asks you 2 questions. It says left bound and it says right bound. So what it's asking for is it says, give me a number that's to the left of the answer and give me a number that's to the right of the answer. So I'm going to tell the calculator -10, I just started typing, -10 is to the left of the answer. So everyone go ahead and type in -10. And then once I've typed that, I'm going to press enter. And once you press enter, what does the calculator ask? So the first thing I did is I said second trace number 2. I said second trace number 2 to look for the 0 of the graph, and the calculator asked me for the left bound. And I typed in -10, and then the question was, It means that you typed in 2 things. So start over again. So hit second trace, number 2. And it'll ask you left bound. Go ahead and type -10. And then the next, it means you're typing enter multiple times. Are you going down to number 2 and not using number 1? So second trace. Number 2, if you type in number 1, it only lets you type in 1 number. If you type in number 2, the 0 of the graph, it should let you type in more than one number. And then after that, it should ask you for a right bound. There should be things. Oh, are you typing in negative right here? This negative? Because you're using this negative. So this is a minus, like you're subtracting a number, but if you're typing in a negative number, you have to use this down here. Does that make sense? Okay. Did that clear it up for everyone? Okay. Okay, so now it's going to ask you for the number on the right, and I'm just going to type in 0. So I typed in left bound, I typed in right bound. When I type enter the next time, it's going to say that it's guessing for me. The guess is always stupid. It's never a good answer, so I'm always going to ignore the guess. And then next, I'm just going to hit enter, and then it will give me the answer. So this is the X-Intercept. Did everyone get that? Okay, so we're going to write that down. I always write to 3 decimal places because on the later on in math, they always use 3 decimal places, so that's just a habit that I developed. But I think on the Math 3 test, they do 1, 2, or 3 decimal places depending on the problem. So I just consistently ask for 3. So I'm going to do negative 0.571. Does anyone know why I put 571 even though the calculator says negative 0.570? I rounded it. Perfect. Okay. Now we have another X-intercept. It's on the other side. Now this one's on the right side, so I'm going to say that the point is between 0 and 10. So I'm going to go through the same process again, but this time for my left bound I'm going to type 0, and for my right bound I'm going to type 10. I'm just going to look between 0 and 10. So I'm going to do second trace, option number 2, and for my left side I'm going to type 0. For my right side I'm going to type 10. And then it gets my other X-intercept. Were we all able to get that? This is a really helpful trick. So in Math 2, they were expecting you to find X-intercepts by hand. In Math 3, we stop finding them by hand. We only find them in a calculator. We do this quickly, but we do it on all different types of equations.
Well, this week was not good last year because that's a lot of steps.
It is a lot of steps, but we're going to do it the same way for all functions. So this is the... It's repetition, yeah. So what I'm going to write above this is I'm going to write second trace, number 2. Second trace, number 2. So that was the menu that we did to get there. We did second trace, number 2, and then left bound, right bound. It's the steps that it feels like a lot, but they're very consistent. So you'll get to the point where it will just be like, oh yeah, that's what we do. Okay. All right, let's try the next one. The next one is the Y-intercept. And if you guys remember, for a Y-intercept, you take the X value and you just always plug 0 in for it. So for the Y-intercept, we're still going to do second trace because that's the thing that we do to get to our menu. But this time we're going to go to number 1 because second trace number 1 lets you plug any value in for X that you want, as long as your calculator screen is big enough. So right now the calculator screen that we have is from -10 to 10, so I can plug in any number that's between -10 and 10, and the calculator will give me the answer. So right here, I did second trace option number 1, and the X value that I want to plug in for a Y-intercept is always going to be 0. So 0 is the one that I'm most interested in, but if they said plug in 1, I could plug in 1. If they said plug in 5, I could plug in 5. If they wanted to say plug in 3.2, I could plug in 3.2. So whatever they want me to plug in, I can plug in. So I'm going to do second trace number 1, and I'm going to plug in X equals 0. That's how I find the Y-intercept. And then it just pops out the answer right away. So the answer is 0, and then -1.142. There's your Y-intercept. Is there anything with the calculator I need to show you how to find again? So how do we get the absolute value to show up on the screen?
Second trace one.
No, just the absolute value sign. You're close. It wasn't second trace. That was the menu to find different things when the graph is already there. Yeah, you hit the math button. You hit the math button. So if you want the absolute value sign, you hit the math button. You go over to the right. That's a certain type of number. Absolute value is a certain type of number. And then it's the first one. Okay. Now, if you forget any of that, you can just be like, Ms. Rice, how do I get an absolute value sign on the calculator? And I'll just remind you real quick. Okay. All right, let's go to the next one. It says we want to be able to describe whether or not a graph is continuous. And in later levels of math, it gets more complicated. But in Math 3, it's very easy to describe. You say whether a graph is continuous if you can trace it with your finger without picking up your finger. So for these graphs, it's a V-shaped graph. We start on one end. We trace the V, we don't pick up our finger to do it, and so absolute value functions are always continuous. So for this particular unit, that's an easy question to answer. If they say, is this equation continuous, you say yes, always. Doesn't matter what they do to the equation, the answer is always yes. Because you don't have to pick up your finger to trace a V. You can trace the whole V without picking up your finger. Okay, now the last part is called end behavior, and it is just describing which way the arrows go, but it's describing it using math notation. So arrows can go two different ways. The arrows can go to the left and to the right, but they can also go up and down. Does that make sense? Arrows can go to the left and right, but they can also go up and down. So we're going to label the different types of infinities that we have based on our arrows. So arrows that go left and right have to do with x values. We already kind of talked about that with increasing and decreasing. And with the increasing and decreasing with the x values, if an arrow went to the left, we said it was a negative infinity. If an arrow went to the right, we said that was a positive infinity. So that's how we think about our left and our right arrows. If we have arrows that go up and down, we think of those as y values. So if we have an arrow that goes down, do we think of that as a positive or a negative? An arrow that goes down, do we think of that as a positive or a negative? A negative. So I'm going to say this is a negative infinity because that arrow goes down. And then this arrow goes up. So is this arrow a positive or a negative? It goes up, so it's positive. Okay. So when we look at our pictures and we have the V's, we have this arrow right here. It goes to the left, but it also goes up. So we're going to describe that it goes to the left and that it goes up, but we're going to use math notation to do it. Okay? So I'm going to say, as I look at, hold on, forgot to put the X in there. As I look at the left arrow. So this is how I write mathematically that I'm looking at the left arrow. So x goes to negative infinity. That's how I say left arrow. Does that make sense? X goes to negative infinity. This is how I write left arrow. X goes to negative infinity. That's how I write left arrow. And then does that arrow go up or does it go down? It goes up. So I'm going to say the y is positive infinity because the left arrow is also an up arrow. The left arrow is an up arrow. Does that make sense? Now look at this side over here. As x goes to something, y goes to something. Now for this one, I want to say that the right arrow is an up arrow. So how do I say right arrow? Do I want positive infinity or negative infinity? Positive infinity. Okay, so I just said right arrow. And then over here, I want to say that the right arrow is also an up arrow. And so how do I say that it's an up arrow? Positive infinity again. So positive infinity means right arrow, up arrow. Okay, let's try to write the other one. So we're going to say if we look at this one right here, we have this arrow over here. How should we write it? Negative infinity. So we're going to say, okay, this one is a left arrow. It's a left arrow that points up or down? Down. Yep. Okay. And then the other one, this one over here, what is this one? Which way does this one point? Points down. Does that go right here or right here? Yeah. So if you're going to say it points down, should that go with the x value or the y value? The y. So saying it goes down, that goes with the y value. Okay, so this arrow goes down. Where else does it go? Huh? That's the down part. To the right. It goes to the right. So if we're going to write it for the x and we're going to say it goes to the right, is that a negative infinity or a positive infinity? It's a positive infinity. Okay. So the part of this that we do not have to write is saying, oh, the left arrow goes up, the right arrow goes down, that sort of thing. We don't have to say that. The part you do have to write is the funky notation with the infinities. That's the part that they actually want to see. As x goes to negative infinity, y goes to negative infinity. As x goes to positive infinity, y goes to positive infinity. But what they're really asking is, tell me which way the arrows go. That's what they're really asking. Okay, now this part though, and like I said in the video from last night, all these notes, they seem like a lot for right now, but it's the same for every single unit. It's the same for absolute value. Then we're going to talk about quadratics. It's the same for quadratics. It's the same for cubics, cube root, square root, log functions, exponential functions, rational functions. It's the same for all of them. So this is going to feel very repetitive. Does that make sense? Okay. So that's kind of the nice thing, is that it feels difficult right now, but then it's going to get a lot easier. Okay. So I'm going to go ahead and give you guys the assignment that goes with this. And I think because we took a while on those notes, I'm not going to give you guys a video for tonight. Okay?